Lesson 8-6 talks about, yesterday we put a line in the middle of the scatter plot. Today we're going to talk about finding the equation of that line that fits the data. In this chart here you see that there's crocodiles, different kinds of crocodiles, and how much they weigh and how hard they bite. And if you notice, the scatter plot is done for us down below here. And we can tell by looking at this data that it typically is a positive relationship between how much they weigh and how hard they bite. So for 67, it's a positive relationship, which means as the weight or the mass increases, the bite force also increases. The next question says to draw a trend line through the data. So what we're going to do, we're going to do that during class, because then the next question says, asks about the actual equation itself, which would be easier to explain when we do it in class. So we're going to do these two together during class. On the question 70 gives a bunch of scatter plots and lines drawn. So we're going to talk about these and why would they be good or bad. If you look at Sol's line up above, it doesn't look too bad. But the problem is when he gets out here, the line is above all the points, and over here the line is below all the points. So you actually want to be through the middle of most of the points. So the problem with Sol's line, we're going to say he underestimates for lighter crocodiles, I'll just abbreviate crocs, and overestimates for heavier crocs. So the problem with his is that it's not really through the data. Part of it's above and part of it's below. Patty's line is next, and if you look at Patty's line, that looks pretty good. It's through most of the points. So we're going to say that Patty's line is very good. And it's generally through the middle of the data. So that's kind of what you want your line to look like when you draw it. Marissa's line, if you notice, pretty much her line is above all the points, which is that you don't want that either. You want to go through the middle. So Marissa's line is above all data points, or most data points. And if you notice Taylor's line, they did the opposite. Most of the points are above the line, so she did the reverse of Marissa. So her line is below most of the data points. So out of the four, Patty's is probably the best place. That's kind of what you want to do when you make your line. Question 71 refers back to that scatter plot on the last page. That's why we kind of want to skip it so you talk about it and the equation. So we're going to skip that question for now. 72, Patty drew line segments from 2 points in her scatter plot. The first was for a dwarf crocodile, this one here, and the next was for an Indian gharial croc. And the question says which line would have resulted in a predicted bite force that was closer to the actual. And if you notice, we're looking for one that's closer to the line. So the dwarf croc would give us a better value because it is closer to the line. Would it be preferable to describe a trend in a scatter plot using a line that makes the differences in the actual and predicted values large or small? We want the values to the line to be small because then it's closer to the line. So as small as possible. Closer the better. If we get on the line, that's even better because that means the line we draw is exact values. Closer to the line results in more closer to the actual. It's kind of worded weird. Sorry about that. We could have got rid of this. Closer to the line results closer to the actual values. So we want our points to be closer to that line. Okay. 73, here's another scatter plot. I'd like you to describe what that shows. We've done a few of these. Just tell me what kind of relationship that is. Part B, she drew a line through the points, and it was nice because it went through 2 exact points. So explain why these points are going to make finding the equation easier. They are exact points. So finding the slope and y-intercept is much easier. So if I have 2 points, it's easier to find the slope and y-intercept because they're exact values. So part C pretty much explains how we do that. What we're going to do to find the slope is we take the y values, the change in the y values, so 12,000 minus 6,000, and we divide that by the change in the x, 7 minus 13. When we do that, we get 6,000 over negative 6, which is negative 1,000. So our slope is negative 1,000. Now I need to find the y-intercept, and what I do is I use y equals mx plus b. I use one of the points from above. I'm going to use 7, 12,000. And I'm going to plug in 7 for x and 12,000 for y. I know the slope is negative 1,000. And now all I have left is b. So I want to find out what b is. And I do that by solving the equation for b. So negative 1,000 times 7 is negative 7,000. I add that to both sides. So 19,000 equals b. That's what I want. So my equation is going to be y equals negative 1,000x plus 19,000. Based on the line, for which car in the data set would the predicted value based on the line be farthest from the actual? Well, the one that's farthest from the line, if you notice this point right here, at 10 years is not even close. So the car that is 10 years old is farthest from the line. Letter E, what does the equation predict for the cost of a 10-year-old car? So our equation was y equals negative 1,000 x plus 19,000. And I'm going to plug in 10 for x because that's how old it is. So I get negative 10,000 plus 19,000. And I get $9,000. And if you notice, the actual on the plot or the chart was 4,040. So it's very far away, like we predicted. So our difference between what we thought and the actual is 4,960. I subtract 9,000 from 4,040. So it's off by quite a bit. Is 5,000 typical of the differences between predicted and actual? No, because this one is farthest away. Most of the differences would be smaller. Remember, all the other points were closer to the line. Most points actually, when you figure it out, are within $1,000 of the actual. So the closer we are to the line of the points, the more accurate the data will be. That's what we want to try and shoot for.